You're listening to leadai.dev, your daily updates on AI development. Today's topic is Agentic AI data gaps expose enterprise real-time processing challenges. Here's a quick overview. Agentic AI systems are revealing critical data infrastructure gaps as enterprises struggle to meet real-time processing demands, forcing organizations to rethink their data strategies. Now, let's ask our analyst about these developments. What's new? Agentic AI exposes critical enterprise data infrastructure gaps.
Agentic AI systems are creating unprecedented pressure on enterprise data infrastructure, revealing critical gaps in real time processing capabilities that organizations previously overlooked. Unlike traditional AI applications that operate on batch processing or scheduled workflows, agentic AI requires continuous access to fresh, contextual data to make autonomous decisions across complex business processes. This shift has exposed fundamental limitations in how enterprises architect their data pipelines, storage systems, and integration layers. The technical challenge stems from agentic AI's need for sub-second response times while processing multiple data streams simultaneously. These systems must correlate information from customer databases, inventory systems, financial records, and external APIs in real time to execute tasks like dynamic pricing adjustments, automated customer service escalations, or supply chain optimizations. Traditional enterprise data architectures, built around nightly batch jobs and periodic synchronization, cannot support these demanding requirements without significant infrastructure overhauls. Organizations are discovering that their existing data lakes, warehouses, and ETL processes create bottlenecks that prevent agentic AI from reaching its full potential. The gap between data generation and availability, often measured in hours or days in legacy systems, must shrink to milliseconds for agentic AI to function effectively. This revelation is forcing enterprises to reconsider fundamental assumptions about data architecture, storage strategies, and processing paradigms that have guided IT decisions for decades. Real time data processing requirements have increased from batch based hourly updates to sub second streaming for agentic AI decision making enterprise data silos, prevent agentic AI systems from accessing cross functional information needed for autonomous task execution. Legacy ETL pipelines introduce 424-hour delays that render data stale for time sensitive agentic AI operations. Current data governance frameworks lack protocols for managing continuous data access required by autonomous AI agents. Infrastructure costs for real time data processing can increase 500% compared to traditional batch processing architectures.
Thank you for that analysis. Let's move on. Who benefits from addressing agentic AI data infrastructure challenges?
Enterprise data architects and infrastructure teams face the most immediate impact from these agentic AI data gaps, as they must redesign systems to support continuous data streaming and real time analytics. Organizations with complex, multi system environments, particularly in retail, financial services, and manufacturing, experience the greatest pain points as their agentic AI initiatives stall due to data latency issues. IT directors overseeing digital transformation projects find their timelines extended and budgets inflated as they address previously unknown infrastructure requirements. Mid-market companies with 5,000 employees often benefit most from early investment in agentic AI-ready data infrastructure, as they can implement modern streaming architectures without the legacy system constraints that plague larger enterprises. Software development teams building AI powered applications gain competitive advantages by designing for real time data access from the ground up, avoiding costly retrofitting later. Data engineering teams skilled in stream processing technologies like Apache Kafka, Apache Flink, and real time databases see increased demand for their expertise. Organizations should postpone agentic AI implementations if they lack dedicated data engineering resources or operate on severely constrained IT budgets. Companies with highly regulated data environments may need additional time to develop compliant real time processing frameworks before deploying autonomous AI agents. Smaller businesses with simple, single system operations might find traditional AI automation sufficient for their needs without investing in complex agentic AI infrastructure. Enterprise data teams managing 10 plus integrated systems requiring cross platform real time synchronization, financial services firms needing sub 100 milliseconds decision making for fraud detection and algorithmic trading. E commerce platforms processing thousands of concurrent transactions requiring dynamic pricing and inventory updates. Manufacturing operations coordinating supply chain production. And logistics data for autonomous optimization. Healthcare organizations integrating patient data, scheduling, and resource allocation for AI driven care coordination.
Great insight. Really helpful context. How to get started. Building real-time data infrastructure for agentic AI.
Begin by conducting a comprehensive data flow audit to identify current latency bottlenecks and integration points across your enterprise systems. Map data dependencies for your planned agentic AI use cases, documenting source systems, required refresh rates, and downstream consumers. Establish baseline metrics for data freshness, processing times, and system response rates to measure improvement as you implement real time capabilities. Configure your streaming data infrastructure starting with a message broker like Apache Kafka or Amazon Kinesis to handle high throughput data ingestion from multiple sources. Implement stream processing frameworks such as Apache Flink or Kafka Streams to transform and enrich data in real time before routing to your agentic AI systems. Set up monitoring and alerting for data pipeline health, latency spikes, and processing failures to maintain system reliability. Deploy real time databases or in memory data grids like Redis Enterprise or Apache Ignite to provide sub millisecond data access for your agentic AI agents. Implement change data capture CDC tools to stream database modifications directly to your processing pipeline, eliminating batch based synchronization delays. Test your infrastructure with synthetic agentic AI workloads to validate performance under expected production loads before deploying autonomous agents. Install Kafka Connect with CDC connectors for your primary databases to stream changes in real time. Configure Kafka topics with appropriate partitioning strategies based on your agentic AI data access patterns. Deploy Flink or Kafka Streams applications to process and transform streaming data for AI consumption. Set up Redis or similar in memory storage for frequently accessed reference data and caching. Implement monitoring dashboards tracking data latency, throughput, and processing errors across your pipeline. Create data quality checks and validation rules within your streaming pipeline to ensure AI input accuracy.
That's a very interesting point. Tell us about competitive context. How agentic AI data requirements change market dynamics.
Traditional enterprise AI platforms like IBM Watson and Microsoft Azure AI struggle with agentic AI data requirements due to their batch processing heritage and complex integration overhead. These platforms excel at scheduled analytics and reporting, but lack the real time streaming capabilities that agentic AI demands. Cloud native solutions from AWS with Kinesis and Lambda and Google Cloud with Dataflow and Pub/Sub provide better foundations for real time data processing, though they require significant architectural expertise to implement effectively. Specialized agentic AI platforms like LangChain and AutoGPT offer built in real time data integration capabilities, but they often lack enterprise grade security, compliance, and scalability features. Open source stream processing frameworks provide maximum flexibility and cost control, but demand substantial internal expertise to deploy and maintain. The competitive advantage now lies in organizations' ability to implement and operate real time data infrastructure rather than simply selecting AI models or platforms. Current limitations include the high complexity of managing distributed streaming systems, increased infrastructure costs for real time processing, and the scarcity of experienced stream processing engineers. Most enterprises underestimate the operational overhead required to maintain 24/7 streaming data pipelines with enterprise grade reliability and security. The learning curve for teams transitioning from batch based to streaming architectures often extends project timelines by 6-12 months. AWS and Google Cloud provide comprehensive real time data services but require deep architectural expertise. Traditional AI platforms lack native streaming capabilities needed for agentic AI implementations. Open source solutions offer flexibility but demand significant internal engineering resources for maintenance. Specialized agentic AI platforms provide easier integration but may lack enterprise security and compliance features.
Good analysis. Let's continue. What's next? Future evolution of agentic AI data infrastructure.
The next 18 months will see the emergence of purpose built agentic AI data platforms that combine real time streaming, vector databases, and AI orchestration in integrated solutions. Major cloud providers are developing managed services specifically designed for agentic AI workloads, reducing the complexity of building custom streaming infrastructures. Edge computing integration will become critical as agentic AI systems require local data processing capabilities to minimize latency for time sensitive decisions. Database vendors are introducing native agentic AI integration features, including built in vector storage, real time change streams, and AI optimized query engines. The convergence of operational and analytical data stores will accelerate as organizations demand unified platforms that support both transactional processing and AI inference without data movement delays. Expect standardized APIs and protocols to emerge for agentic AI data access, simplifying integration across heterogeneous enterprise environments. Organizations that invest in real time data infrastructure now will gain 12 to 18-month competitive advantages as agentic AI adoption accelerates across industries. The skills gap in stream processing and real time architecture will drive increased demand for specialized consulting services and managed platform offerings. Companies that delay infrastructure modernization risk being locked out of advanced agentic AI capabilities as the technology becomes table stakes for digital competitiveness. Managed agentic AI data platforms from major cloud providers expected by Q2 2025, database vendors adding native AI integration and real-time streaming capabilities, edge computing integration becoming standard for latency-sensitive agentic AI applications, standardized protocols for agentic AI data access, reducing integration complexity.
Great analysis. So, what are the key takeaways from all of this?
Agentic AI requires sub-second data processing capabilities that expose critical gaps in traditional enterprise batch-based architectures. Organizations must implement streaming data infrastructure with message brokers, stream processors, and real-time databases to support autonomous AI agents. The competitive advantage shifts from AI model selection to real-time data infrastructure implementation and operational excellence. Early investment in agentic AI-ready data architecture provides 12 to 18-month competitive advantages as adoption accelerates across industries.
And what market signals should our listeners watch for?
Infrastructure investment surge. Enterprise spending on real-time data processing infrastructure is accelerating as organizations recognize that agentic AI cannot function effectively with traditional batch-based systems. Cloud providers report 0% increases in streaming service adoption, while specialized vendors like Confluent and Databricks see growing demand for real-time analytics platforms. This infrastructure investment wave indicates that enterprises are moving beyond pilot projects to production-scale agentic AI deployments that require robust, always-on data pipelines. Skills gap expansion. The demand for stream processing and real-time architecture expertise is outpacing supply as organizations struggle to find engineers capable of building agentic AI data infrastructure. Salaries for Apache Kafka, Flink, and real-time database specialists have increased 35% in the past year, while consulting rates for streaming architecture projects reach premium levels. This skills shortage is creating bottlenecks in agentic AI adoption timelines and driving increased investment in managed platform services and external consulting partnerships. Platform consolidation pressure. Traditional enterprise software vendors face pressure to integrate real-time capabilities or risk obsolescence in the agentic AI era. Database companies are acquiring stream processing startups, while AI platform providers are building native data streaming features to remain competitive. This consolidation trend suggests that standalone point solutions will give way to integrated platforms that combine data infrastructure, AI orchestration, and real-time processing in unified offerings designed specifically for agentic AI workloads.
What should developers and operators do with this information?
Audit current data latency across systems within 30 days to identify agentic AI readiness gaps and infrastructure requirements. Implement proof of concept streaming pipeline using Kafka and Flink within 60 to 90 days for one high-value agentic AI use case. Deploy real-time monitoring and alerting for data pipeline health before moving agentic AI systems to production environments. Train internal teams on stream processing technologies or engage specialized consulting partners for complex enterprise implementations.
Thank you for listening to leadai.dev. Stay tuned for our next daily updates in this rapidly emerging market.